Today we are going to continue with the mole concepts. The mole concepts. Recall that the last time we talked about the mole, we discussed the mole and the mass of compounds. The mole and the mass of compound, which we call the molar mass. We talked about that the molar mass of a compound is the mass of 1 mole. And then we also talked about the mole and the mass of elements. The mole and the mass of elements. That is to say, the mole is equivalent to the mass of elements, or the relative atomic mass of an element. Recall we said that mole is the amount of substance that contains the same number of specified particles. So today we are going to look at those specified particles and in relation with the mole. So we have the mole and the Avogadro's constant L. So the mole, or 1 mole, is equivalent to Avogadro's constant. 1 mole is equivalent to Avogadro's constant, which is 6.02 times 10 raised to the power 23 particles. So these particles we are talking about may be ions, molecules, and atoms, as well as electrons. The particles we are talking about in Avogadro's constant may be molecules, maybe ions, maybe atoms, maybe electrons. So what is the relationship between 1 mole of a substance, the particles, number of particles in that 1 mole of a substance, and the Avogadro's constant? So we now have 1 mole is equivalent to number of particles. Remember, these particles could be ions, atoms, molecules, and electrons. It can be any one of them, divided by Avogadro's number. Avogadro's number. So let's take a question now. How many atoms? How many atoms are there in 20 moles of calcium, given that Avogadro's number is equivalent to 6.02 times 10 raised to the power 23. So the mole or amount, mole, number of moles or amount. Number of moles or amount is equivalent to N, which is number of particles, divided by L, which is Avogadro's number. And that tells us that for this problem, the number of moles, which is 20, and Avogadro's number 6.02 times 10 to the power 23. So we make N the subject of the formula. How many atoms means what is the number of atoms? Determine the number of atoms. Remember, we said number of particles, number of atoms is given as the symbol with is represented by the symbol capital letter N. So here we have number of atoms is equivalent to number of moles or amount multiplied by Avogadro's number, and that is 20 times 6.02 times 10 raised to power 23. I will put what? Atoms. And that will give us 12.046 times 10 raised to power 24 atoms. Question we are going to treat here is this. Calculate the number of oxygen molecules contained, the number of oxygen molecules contained in 1.11 moles of the gas at standard temperature and pressure. Given that L, that is Avogadro's constant, is equivalent to 6.02 times 10 raised to power 23. Calculate the number of oxygen molecules. We are talking about number of molecules. Remember, we say the number of entity, the number of particle could be number of ions, could be number of atoms, could be number of molecules, or even number of electrons. So let's calculate. Going by our formula that number of moles N is equal to number of entity N, big N, divided by Avogadro's constant. So since we are looking for the number of molecules, we make capital letter N the subject of the formula. We now write N is equivalent to the number of moles multiplied by the Avogadro's constant, and that is 1.11 times 6.02 times 10 raised to power 23. We now add molecules, and that gives us 6.68 times 10 raised to power 23 molecules. It's a relationship between the number of particles, Avogadro's constant, and the number of moles or amounts. Recall that the 1 mole contains, the 1 mole of any substance contains 6.02 times 10 raised to power 23 particles. Recall that the number of particles can be determined using the relationship between the number of moles and the Avogadro's constant, and then the number of entities, just by multiplying the number of moles with the Avogadro's constant. Thank you.